Hi everybody, welcome back to the section 4.2 video. In this video, we're going to take a look at another example where we need to use reduction of order to get a second solution to a second order linear differential equation. So in this example, we're given a solution to this differential equation in y1. So y1 equals square root of x times natural log. And this is a solution to the second order differential equation 4x squared plus y double prime plus y equals 0. So we want to find a second solution, y2, of the differential equation to form a general solution. So here we're going to use reduction of order to get this second solution. So I have the formula right here as well. So let's go ahead and figure out the second solution. So solution, we are given y1 equals square root of x times natural log of x. And we want a second solution, y2. So we're going to use reduction of order. So before we use reduction of order, we got to get this differential equation into standard form. So get into standard form. And so what we need to do is we see a 4x squared is attached to that y double prime. And so what I need to do is divide by 4x squared. And so when we do divide by 4x squared, what we get is y double prime plus 1 over 4x squared times y and just equals 0. Okay, so we have a bit of an issue here in that our p of x is always attached to our first derivative. It's always attached to a y prime, but I'm missing a y prime here. So what I need to do is take account of that missing y prime. So what I would write is y double prime plus 0y prime plus 1 over 4x squared y equals 0. And so this 0 right here is my p of x. And so I need to find my integrating factor for this question. So it would be e to the negative integral of p of x d of x. And so I need to integrate the integral of 0 dx. And what is the integral of 0? Well, the integral of 0 is just going to be c. Why is that? Well, because the derivative of a constant is just going to be 0. So the antiderivative of 0 is just going to be a constant. And so to make this even easier for us, e to the negative c, well, that's just another constant. We'll call it d. So d is just my integrating factor. So I have my integrating factor. I want to find y2. Let's go ahead and figure that out. So let's call it reduction of order time or formula time. Okay, so let's rewrite the formula. Y2 equals the y1 times the integral of e to the negative integral of p of x all over y1 squared dx. And so let's plug in what we know so far. So y2 equals y1, which is square root of x times natural log of x times the integral of just d all over square root of x squared, excuse me, square root of x times natural log of x squared dx. Okay, so let's see how this turns out. So I need to square that square root of x times natural log of x. So that turns into square root of x squared is going to be just x, and natural log of x squared is just still natural log of x squared. Okay, so how do I solve this integral? This looks a little funky right now. Well, it actually turns out that I could just use u sub. So we would let u just be that natural log of x, and du would be 1 over x dx. And so when I substitute in, my integral just becomes u squared du. And when I integrate, this would be du to the negative 2 du, and I get, oops, sorry, I get d times negative 1 over u. And so we plug back in what u is. U is just natural log of x. Oops, sorry, got the negative. And this works out quite well. The natural log of x's cancel out. And so what I'm left with is just a negative constant d times square root of x. So that's my y2. Okay, so my general solution, remember it's y equals c1y1 plus c2y2. So let's plug in what we know. It's y equals c1 and my given solution square root of x, natural log of x, plus my c2 times negative d root x. But we have a weird situation here. We have two constants. We have c2 and negative d. Well, a constant times a constant is just another constant. And it doesn't really matter whether a constant is positive or negative. So what we can just rewrite this as is c1 square root of x natural log of x. We could just say plus c2 square root of x. It's just another constant. We don't know what it is. So we could just rewrite it as plus c2 and combine those constants. But that is the answer. We got our second solution to this second order differential equation, and we're able to write up our general solution of linearly independent solutions. Okay, so That's it for this video. Thank you for watching. I'll see you in the next one.